Section 4.2.5t. The data set is given below here. We can see that the values for x are 1, 2, 3, 4, 5, 5, 6. The values of y are 5.0, 5.7, 4.7, 3.3, 2.9, and 2.7. We want to be able to draw a scatter diagram and then comment on the type of the relation that appears to exist between x and y. Now, two variables that are linear related are positively associated if, whenever the value of one variable increases, the value of the other variable tends to also increase. Similarly, two variables that are linear related are negatively associated if, whenever the value of one variable increases, the value of the other variable tends to also decrease. So we're going to go ahead and open up this data in StatCrunch. So here is our data table. We're going to go ahead and open that up. Okay, and then what we're going to do is we're going to go ahead and create a scatter diagram. So we're going to go ahead and select graph and then scroll down to where it says scatter plot. Okay, and our x variable is going to be x. We know that our y variable is going to be y. Okay, and then we're going to go ahead and then select compute. Okay, and so now the only thing that we want to do is let's make sure that our y-axis goes, I say that x goes from 0 to 6. Okay, so we're going to go from 0 to 6. And then we're going to let our y values also go from 0 to 6, just to give us a better representation of what this graph is going to look like. So therefore, now we can see what's happening with our scatter diagram. Okay, so here's our scatter diagram. The one you would choose as a multiple choice would give the following, so it's very similar here. Again, we're going from 0 to 6 and 0 to 6. So what can we say about this data? So we're going to use the information that we were just been given. So what we can say here is the following. We can see that the scatter diagram appears to be a linear association because they're kind of grouped together over here. Okay, and the association is going downward, so therefore it appears to be negative. Okay, next. Given that the sample mean for the sample of x's is 3.8333, the standard deviation of the values of x is 1.9408. The means of the y values is 4.0500. The standard deviation of the y values is 1.2454. And the correlation coefficient r is equal to negative 0.8895. We want to determine the least squares regression line. So the first thing we're going to do is do it by hand, and then we're going to go ahead and make sure that we can do it by StatCrunch. We want to do it by hand, so first and foremost, we can see that the equation of the least squares regression line is given by y, which is equal to b1x plus b0, where b1 is equal to r times the standard deviation of y divided by the standard deviation of x is the slope of the least squares regression line, and b subscript 0 is equal to the mean of y minus b1 times the mean of x is the y-intercept of the least squares regression line, where we know the given values. So the first thing we're going to do is let's go ahead and find out what b1 is equal to. So using the formula b1, we know it's going to be r times the standard deviation of y over the standard deviation of x. Well, we're given those values. So we know that b1 is going to equal r, which is negative 0.8895. And we're going to multiply that by the numerator, which is the standard deviation of y, which is 1.2454. And then when we multiply those together, we're going to divide it by the standard deviation of x, which is 1.9408. Okay, so we multiply those all out. So plugging that into our calculator, then we get the following, negative 0.570786945. And let's round this to 3 decimal places. So that means we're going to get B1, which is equal to negative 0.571. Okay, and now what we're going to do is now we're going to find B subscript 0. Okay, so which is the y-intercept, and that's going to be the mean of the y values minus B subscript 1 times the mean of x. So we're going to take the value of the y mean we can see up here, which represents 4.0500, and then we're going to subtract what we got for B1. So we're going to use what we got initially, which is 0.5707869435, and then we're going to multiply it by the mean of x, which is 3.8333. And so therefore, let's see what we get for this value. And so we call that's 4.0500. This minus this negative makes that plus. So we end up getting the following value. We get 6.237997591. Now, if we round that to 3 decimal places, then we get 6.238. So now what we've done is we've determined what is the y-intercept and the slope of the line. And remember that this is the equation, which is equal to y, which is equal to b1x plus b subscript 0. So the equation is negative 0.571x plus 6.238. Okay, now, yes, these are the formulas that we could use to do this by hand, but can we quickly get this done by using StatCrunch? Well, yes, we can. So let's go ahead and do that. So if we take a look at this data here, okay, what we can do is we can go ahead and select stat, and then go to regression, and then select simple linear, okay, and then we have our variable for x, and then we have our variable for y, and then we're going to select compute, and then we can see that we have up here this equation. So let me go ahead and copy and paste that. So let's go ahead and match what we have for our result. We can see that the y-intercept is 6.238, and we can see that the slope is rounded to 3 decimal places is minus 0.571. And so therefore this problem we can then say that the least squares regression line is y is equal to negative 0.571x plus 6.238. Okay, now the next thing they want us to do is use technology to plot the line y is equal to negative 0.571x plus 6.238 on the same diagram as a scatter diagram in part A. So let's go ahead and do that. So we're going to go ahead, and then we're going to go ahead and we have our data in here. We're going to select graph, and then again select scatter plot. We have our value for x, we have our value for y. Okay, and now what we want to do is we have our slope, which is negative 0.571, and we have our y-intercept of 6.238. So you see where it says overlay polynomial order. We're going to go ahead and select that, and then we're going to go ahead and put in 1. And then we're going to select this option here where we have y, which is equal to C0, which represents the y-intercept. So the y-intercept is 6.238. So we're going to put in a value 6.238. Okay, and then the next thing we want to do is we're going to put in the slope. The slope is negative 0.571, but do not include the x. So we have negative 0.571. Okay, and now we're going to go ahead and select compute. And so now we have our graph. Okay, let's go ahead and make sure that our x-axis goes from a minimum of 0 to 6. And then our y also goes from a minimum of 0 to a maximum of 6. Okay, and so therefore there is our graph okay, and then let's compare that to the result of what it would look like here. So therefore there is your result.